Salam and welcome everyone. So today I am just compiling a bunch of shorter videos from my channel for any student who is reviewing your physical chemistry for an exam or for a test. The goal of this video is for you to review the examples that I've done already on this channel from the physical chemistry Atkins textbook. It is to help you in your journey through physical chemistry, whether you're about to take a test or whether you're doing a bunch of problem set. I wish you guys all the very best. Please enjoy the video. Salam. So today we're going to be working on the question on the screen that says, what is the efficiency of an ideal heat engine in which the hot source is at 100 degrees Celsius and the cold sink is at 10 degrees Celsius? So the first thing you have to note is that we're asked to find efficiency, okay? And of course, the symbol for efficiency is this one right here. So we're asked to find efficiency. We're told that the hot sauce is at 100 degrees Celsius. So T of hot is 100 degrees Celsius. So the temperature of the hot sauce in Kelvin would be 100 degrees Celsius plus 273.15. So the temperature of the hot sauce is 373.15 Kelvin. And then we're also told the temperature of the so-called sink is 10 degrees. So the temperature, okay, of the cold sink is 10 degrees Celsius. We have to convert from degrees Celsius to kelvins. So that would be temperature of the cold sink would be 10 degrees Celsius plus 273.15. So the temperature of the cold sink is going to be 283.15 Kelvin. So that's basically what you need to know. And since we're asked to find the efficiency, we have to remember to use the formula for finding CARNOT efficiency, which is, of course, the efficiency symbol equals to 1 minus the temperature of the cold sink divided by the temperature of the hot source. After this, all you have to do is just simply substitute, right? So you have efficiency equals 1 minus TC, which is 283.15 kelvins, divided by 373.15 kelvins. Of course, you cancel out the kelvins. You do 283.15 divided by 373.15. So this is equal to 1 minus 283.15 divided by 373.15 would give you 0.7588. So the efficiency is now going to be equal to 1 minus 0.7588 would give you 0.24119. Now, remember that our question, we were given 10 degrees, we're given 100 degrees, and you may be wondering what is the correct number of sig figs that we're supposed to put this question in. Well, normally you're supposed to go with the lowest number of sig figs. So that would just mean whatever 10 degrees Celsius sig fig is, which is 2 sig figs. So we're just going to say the efficiency is actually 0.24. So this is the value for efficiency. And again, it's possible for you to have it in your question where your teacher asks you to put it in 3 sig figs in 2 decimal places. Just follow the rules. So this one now is in 2 sig figs. If you were asked to write this in 3 significant figures, it would be 0.241 for the efficiency. So just pay attention to the number of sig figs that I asked you. If they didn't tell you in the question, if they didn't tell you the number of sig figs in the question, just look for the lowest number of sig figs that was given to you in terms of the information given in the question. So if you have any questions, make sure you put it in the comment section. If you have any concerns or suggestions, also ask or put it in the comment section. Salam and welcome everyone. So today we're going to be working on the question on the screen that says, an ideal heat engine has a hot source of 40 degrees Celsius. At what temperature must the cold sink be if the efficiency is to be 10%? So the first thing you have to note is that we've been told the temperature of the hot sauce. So the temperature of the hot sauce is 40 degrees Celsius. And as we know in chemistry, we have to, anytime we're giving degrees Celsius, we have to go to kelvins. So we just have to say temperature of hot sauce would just be the 40 degrees Celsius that we know plus 273.15. So the temperature of the hot sauce becomes 313.15 kelvins. Now we're also told to ask, they also asked at what temperature must the cold sink be if the efficiency is to be 10%. So we see that the temperature of the cold sink, we absolutely don't know what that is because For those of you who don't know, we're dealing with an ideal heat engine. So there's usually a hot source, okay, and then there's also a cold sink. So we were told that the cold sink is what we're going to be looking for, and we're supposed to determine what that is if the efficiency, which is just this, is 10%. Now, if you notice, I didn't say 10%, I said 10 divided by 100. And the reason why I'm going to do that, I'm going to explain in a second. Or the reason why I did that, I'm going to explain in a second. You have to note that for efficiency, the formula is simply this formula right here. Efficiency equals 1 minus temperature of the cold sink divided by the temperature of the hot sauce. So that is basically the formula. So now, dude, that's the whole point why I'm putting this in 10 divided by 100, because efficiency is usually a value basically that would end up being like a decimal. Majority of the time, it's a value that is in decimal. So that's the reason why I have to go from percent to fraction, and then, of course, from percent to fraction to decimal. So 10 divided by 100 is the same thing as 0.10. So we have the temperature of the hot sauce. We have the temperature of we have the value for efficiency, and we're supposed to determine that of the cold sauce. But before we go ahead, let us not forget that we can rewrite this formula so that it's easy for us to do the math. We can say efficiency, okay, using this formula right to the left, minus 1, okay, is equal to negative TC divided by TH. So this is just basically something that can happen. So when we have this, we can just simply substitute what we have. Substituting what we have, let me make this like a two-part system. So let me rewrite this. My is equal to negative TC divided by TH. So the efficiency will be 0.10 minus 1, okay? Negative TC, okay? So since it's the temperature of the cold sink, divided by 313.15 kelvins. So 0.10 minus 1 is the same thing as negative, okay? Negative 0.90 equals to negative TC divided by 313.15 kelvins. Of course, you cancel out the negative, cancel out the negative. So what this is ends up being is, I'm just rewriting it. So you end up with 0.90 is equal to TC divided by 313.15 kelvins. Okay. So of course you cross multiply. So the temperature of the cold sink would be 0.90 times 313.15 kelvins. So the temperature of the cold sink would be 281 0.835 kelvins. So yeah, that's basically it. But the thing is, since we have our temperature and we know it is in 5 sig figs, let's just rewrite this in 5 sig figs. So the temperature of the cold sink is actually going to be 281.84 kelvins. And that is basically how you answer the question. So this is basically the answer to the question. Temperature of the cold sink would have to be 281.84 kelvins in order for you to have an efficiency of 10%. So yeah, that's basically the answer to the question. If you have any questions, please put in the comment section. If you have any suggestions or concerns, also put in the comment section. If you're a student who's trying to succeed in all your STEM related courses, whether you're in middle school, high school, or college level, I am the tutor for you. I help students succeed as well as improve in all your STEM related courses throughout the academic career. So if you would like to know about my services or would like to book, even if it's a free session, you can email me at shahabitutoring@gmail.com. Salam and welcome. So today we're going to be working on the question on the screen that says, in a certain ideal heat engine, 10.00 kilojoule of heat is withdrawn from the hot sauce at 273 kelvins and 3.00 kilojoule of work is generated. What is the temperature of the cold sink? The first thing you have to know is this. Let me write out the solution. Is for you to know that you have to write out the parameters. You have the heat of the hot sauce to be 10.00 kilojoule. You're told that the heat is withdrawn from the hot sauce at 273 kelvins. So I'm going to put a negative here because we're talking about the heat of the hot sauce. The hot sauce now has negative 10.00 kilojoule, because the hot sauce has a temperature, it has a particular amount of heat, and part of the heat is withdrawn, meaning it's taken away. So in order for you to know the current value for heat of the hot sauce is going to be negative 10.00 kilojoule. And they said that happened from the first from the hot sauce at 273 Kelvin. So the temperature of the hot sauce is going to be 273 Kelvin. And then we're told that 3.00 kilojoule of work is generated. Okay, so work is 3.00 kilojoule. And the temperature, and we're asked now to find the temperature of the cold sink. So the temperature of the cold sink is what? Now we've been given the heat of the hot sauce, the temperature of the hot sauce, the work done, and we're asked to find the temperature of the temperature of the cold sink. Now, before we do anything, it's important for you to know that this is the formula we're supposed to use. The heat of the hot sauce divided by the temperature of the hot sauce plus the heat of the cold sink divided by the temperature of the cold sink equals to 0. So rewriting this formula, we can have it as the heat of the hot sauce divided by the temperature of the hot sauce equal to negative the heat of the cold sink divided by the temperature of the cold sink. So this is basically this is it. This is 100% it. Now I wanted to mention something. We've been given the heat of the hot sauce. We know that. We know the temperature of the hot sauce. We don't know the heat of the cold sink, but we don't also know the temperature of the cold sink, and we're supposed to solve for it. Now, in order for you to be able to know what's going on here, you have to understand how an ideal heat engine works. In the ideal heat engine, the temperature is gotten from the hot sauce, is withdrawn from the hot sauce. Sorry, not the temperature, the heat is gotten from the hot sauce. Hence, the reason why it's withdrawn, why we have a negative 10.0, and part of that heat is used to generate work, meaning work is done using that heat within the engine. Now, whatever is left of the heat that is not used to generate work is going to be deposited into the cold sink. So the heat of the cold sink is whatever is left over after work is done. So that would simply be the heat. Let me write it up top here. That means that the heat, okay, of the cold sink would be QC is just going to be whatever the heat of the hot sauce is, whatever we used minus the work done. So that's actually going to be 10, okay, 10.00 kilojoule minus 3.00 kilojoule. And you may be wondering, well, we use negative. Why are we not using negative? Don't forget, we only attributed negative for us to know that we're taking from the hot sauce. Like we were taking all of it energy. But that does not mean the heat itself is negative. It's just negative at the hot sauce. So that's the reason why we can just say 10 minus 3. And we know that the heat of the cold sauce is going to be 7.00 kilojoule. So let me just write that up top. So heat of the cold sauce, heat at the cold sink is going to be 7.00 kilojoule. Again, don't forget the negative that we're using for the hot sauce. The heat there is just to tell us that it was taken. It's just to denote the fact that it was taken from the hot sauce. It's not necessary that the value in of itself is negative. So that's one thing. Or if you want to put negative there, I don't know how that would work, but you would have to put like an absolute in between the negative 10.00. You have to put an absolute there. But anyways, 10 minus 3 is 7. So now we have all of the information we need. We just have to simply substitute. So we have 10.00 kilojoule. So we're substituting into this formula, into this equation right here, 10.00 kilojoule, okay, divided by the temperature of the hot sauce. So that would be 273 Kelvin equals negative the QC, which is 7.00 kilojoule, okay, divided by TC, the temperature of the cold sink. So of course, cancel out this, cancel out this. So you cross multiply. So you have 10.00 kilojoule TC is equal to 7.00 kilojoule times 273 kelvins. So divide this by 10.00, divide this by 10.00 kilojoule. Of course, kilojoule. Of course, you cancel out the kilojoule, cancel out the kilojoule, cancel out the kilojoule here, cancel out the kilojoule. So that would be cancel out the 10 as well, because we're trying to find just TC. So TC is just going to simply be 7.00 times 273 Kelvin divided by 10.00. So that would give us the temperature of the cold sink to be 191.1 Kelvins. And of course, since we are since we are working with a question where the lowest number of sig figs is 3 sig figs, we can basically write this in 3 sig figs. So the temperature okay, of the cold sink is actually 191 kelvins. And this is just basically the answer to the question. If you have any questions, please put it in the comment section. If you have suggestions, concerns, put it in the comment section. If you're a student who is struggling with any of your STEM related courses, I am a tutor and mentor for students who are trying to succeed and excel in all your STEM related courses, whether you're in middle school, high school, or college. If you'd like to see the services that I render, or if you'd like to book an appointment, make sure you email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.